Hello. In this video, we will discuss transformation of functions in details. In part A, we dealt with translations and reflection. Here we'll have all the components together. So in general, let us say there is a function fx which has been transformed and we get a function gx. In this, the function is vertically stretched by a factor of a, horizontally compressed by a factor of 1 over k, horizontally translated d units to the right, and vertically translated c units up, in case all these values are positive. Now let me just describe all of them one by one. Important thing here to note is that whatever is there within these brackets, this reflects horizontal translations or stretches or compressions, and outside this bracket indicates vertical. Okay, now a is a vertical stretch or compression factor. Now if the value of a is greater than 1, then we say there is a vertical stretch by a factor of a. That means all the fx values get multiplied by a. But in case a is a fraction, so let me at present write it is between 0 and 1. In that case, it is vertically compressed by a factor of a. Okay, this a is this a, right? Now sometimes you may have a negative thing here. Now this corresponds to reflection vertical reflection on x-axis. What I'm trying to say here is that if this is negative, and let us say we have a graph like this, then if this is negative, then it gets reflected vertically like this, upside down. So the y values become negative, all positive becomes negative, like that, gets reflected. Now, as I was saying, the outside parameters reflect vertical operations in transformations. So let's take up C now. C is what? C reflects vertical translation. In case C is positive, it means up, and if it is negative, it means down. So let's say C is 2 positive, then we'll translate the whole graph 2 units up. If C is negative, then the whole graph gets translated 2 units down. So these are vertical, and now let's consider the horizontal transformations. Okay, now this value of k, if it is a fraction less than 1, that means k is greater than 0 but less than 1. In that case, we say that it is horizontally stretched by a factor of 1 over k. But if k is greater than 1, in that case it is horizontally compressed by a factor of 1 over k. Okay, now we are assuming all these positive values. Okay, in case we have a negative sign here, then this negative sign corresponds to reflection, horizontal reflection, let me write, about y-axis. So what happens in this case is, let's say the graph is like this, it gets reflected like this. Okay? Now, these are the basic things. Let me just make things clear here that we are assuming that negative sign is taken separately. If you are taking this value as a whole, here when we write a, we really mean absolute value of a. Okay, we are just taking the positive value of a. Okay. Now, I hope you understand this part. Again, let me repeat it for your convenience. A, vertically stretched if it is greater than 1, compressed if it is less than 1. And this minus reflects the whole graph about x-axis, that means vertically. And this C is a vertical translation, up or down. If C is positive, it goes up, otherwise down. K, it is horizontal stretch or compression. It stretches if this is less than 1, remember, but it compresses if it is more than 1. Okay, and D is left or right translation, horizontal translation. If D is positive, no, we already have a negative here in the equation, okay. If D is left, for example, 2, then we'll move 2 units to the right. Oh, we didn't write about it. So let's now take D also, right? So for D, let me write about D. Forgot. So D is, oh, we can go here. D is horizontal translation. So if D is positive, then it moves 2 units to the right. To right. And if D is negative, then we move left. Those many units, okay? Anyway, this is one part of it. Next, most important thing is, let us say there are function fx. On a function fx, we have coordinates x and y. Then, after this kind of a translation or transformation, what happens to these coordinates on gx? So they will get changed, right? How will they get changed? Let's try to understand that part now. So original, let's say we have xy, and the transform coordinates, let them be xt and yt. These are the transform coordinates. So how are these two related? Okay, the relation is, we'll just use these properties and show you how they are related. Xt, transformed x value is equal to k value, we are multiplying by a factor of 1 over k, you see that? Yes. So we do 1 over k times x value, original x value. D value gets plus, because if it is positive, you move right, plus D. That happens to the x values. And about the y values, yt's, y value gets multiplied by a to the original y value, and then you add c going up or down. So that becomes your translation of the transformed function coordinates. Okay. We will take a concrete example to show you all this now, but let me also tell you few important things. One is order of transformation. When should we apply which transformation? That is very important, right? So like in bed mass, we do times or multiplication first. And then addition or subtraction, okay? What I'm trying to say is, on the function, first you should do what? First you should do stretch or compression, including reflection. See, reflection is a part of stretch or compression. When we say stretch by a factor of 2, and if it is minus 2, instead of going up, we can go down, right? If we can reflect it at the same time, followed by translation. So first always do stretch and compressions, and then we do translations. Okay. Now you could start from inside out. You could do horizontal stretch and compression, and then you can do vertical stretch and compression. Then you can do horizontal translation and vertical translations. Well, that's one way of doing it. And the other alternative is, so alternate way is move from left to right. Left to right. Left to right, I mean, you can, as you see the equation here, you can start from here. Left, you can go as it comes. For example, here, do reflection and vertical stretches and compression. And then you do reflection and horizontal stretches and compressions. And then you do horizontal translations left or right. And finally, vertical translations left or right. The sequence is very, very important. If you don't follow the sequence, you will end up with wrong graph. Okay, let me give you one example. For example, let's say we have a function fx equals to square root of minus x minus 2. I am purposely taking this function because many times I have seen students making this mistake. So whenever you have a function like this, first thing is factor out the coefficient of x. In this case it is just minus 1, but let's do it. Minus 1. When you factor this out, then we are left with x plus 2. Okay, do you see this? There is a multiplication and this x minus d is in bracket, and we have to factor out any coefficient of x. Perfect? Yes. Now this means what? This means that if we have square root function, this is our square root function, let's say, then what should we do? First we should reflect it, and this is horizontal reflection, okay? And then we should move 2 units to the left, correct? This is plus 2. So how are we going to translate it? First we'll reflect it, okay? This means square root of minus x. Fine. And then we can move it 2 units to the left. So this function is square root of minus x plus 2 as desired. Do you see that? Now that means finally the domain is less than minus 2. Now you can check the domain like this. For example, this was the original function. To check the domain, we can do minus x minus 2 should be greater than or equal to 0, correct? Now we'll take minus to this side, so we get minus x is greater than or equal to 2. Now we will multiply by minus, but when you multiply by minus, you should remember you have to change the sign also, okay? So we do x less than or equal to minus 2. That's what you get here. You see that now? Very important to consider. If you don't do this, for example, if you do translation first, this minus something, I mean, you will land up with a different and altogether a wrong answer. For example, here, if you first do 2 units to the left, it becomes something like this, right? And then reflect, then it becomes something like this. So instead of getting less than minus 2, your domain will be less than 2, which will be wrong. So this is a very, very important point to consider. Don't forget it, okay? Keep in mind. Now, let us take a concrete example. Okay? Now here, I've already drawn a sketch for you. And then we will translate this as per our function. So, this is a very simple function, but it will demonstrate all the techniques required to learn. Okay, so this is a simple line graph. Okay, let's first label the points. So this point is 1, 2, 3, 4, 5, 6. This is minus 6, 0. Let's call it A. And this point is 1, 2, minus 2, and y value is 2. Let's call it B. And this point is 2, 2. Let's call it C. And this point is, let's call it D. And the point is 1, 2, 3, 4, 1. Okay. So these are our coordinate points for the line segments. We want to transform this function using this function. Now here, you see the transformation. We are doing minus 3 f of 2 within brackets times x minus 1 plus 1. Can you tell me what should be the transformation? Let's start from the left side, and I'll prefer to do left to right because in that case we ensure that it will be correct. Now this minus, this reflects what? This minus means reflection on x-axis. This is vertical outside, okay? So it reflects like this. How about this now? This is the k factor. No, let's take 3 first. So 3 is vertical stretch. By a factor of 3. And then 2 is the k value. So because 2 is greater than 1, it is actually compression. Horizontal compression. Horizontal compression. By factor of, can you tell me? Not 2, half, 1 over k. And then we do horizontal and vertical translations. This one is horizontal translation, 2 units, 1 unit, right. And this one, 1 unit up. Correct? Now these are the description of the transformation, and now we will see how the points get transformed. Okay? Now as you remember, we will now transform the points from x original value to these points. Now let's write the original values, x and y points. Minus 6, 0. This is the x value, this is, then b, minus 2, 2, c, 2, 2, and d is 4 and 1. And these points get transformed. I'm making a bigger box to show you the calculations. So what is happening here? First, let me write them. How should they get transformed, right? X values. What is happening to the x values? We are dividing by 2 and adding 1. Okay, so x values become half of x value plus 1. How about the y value? This is xt, right? The y values will become 3 times, minus 3 times. So like minus 3 of y values plus 1. Now let's calculate. 6 minus 6. Half of minus 6 is 3 minus. Minus 3 plus 1, minus 2. And 0 times anything is 0 plus 1. So we get 1. Minus 2 times this will give us minus 1. Minus 1 plus 1, 0. 2 times minus 3 is minus 6. Minus 6 plus 1, minus 5. Now again, 2 times half is 1 and 1 plus 1 is 2. With 2, 2 times minus 3 is minus 6. Minus 6 plus 1 is minus 5. 4. Half of 4 is 2. 2 plus 1 is 3. And for 1, minus 3 plus 1, minus 2. So these are our transform points. Okay. Let's now put these transform points on the graph and see how it looks like. Minus 2, 1. So minus 2 and 1. It comes here. Minus 2, 1. This is the transformation point. This was A, right? You remember? And this becomes A dash. This is A dash for us. This was B. And this becomes B dash. C and D. And this is C dash and D dash. And then goes to 0 minus 5. So for 0, 1, 2, 3, 4, 5. This is our B dash. 2 minus 5. 2 minus 5. 3 minus 2. 3 and minus 2. So this is our transform graph. Let me just join these points for you. That's the transform graph, and this is our function gx. Okay, you can check is it right or wrong. Let's make a quick check. So what is happening here is, to this point, let's first check the x values for this point. For the x values, we know it is half. This was minus 6. Half of minus 6 is, it will come to 3, right? Minus 3. And then moving 1 unit to right. Correct? So you are here minus 3 and then 1 unit right. So this is the x value. X value is correct. Do you see that? How about the y value for this? 0 times minus 3 is 0, and you move 1 unit up, and so we land up here. Perfect? So this is our point A dash. B. So what is half of this? Half is here. Correct? Half of this. Correct? Half. And then you move 1 unit to the right. You move 1 unit, so you come to 0. See, x value is 0. Is that right? Fine. How about the y value? 2. 2 times minus 3, minus 6, plus 1 gives us minus 5. So that ways you can make a quick check. And then you'll figure out that the points match with our working. So this is a way to transform a function. You will see how beautifully we did the transformation with simple calculations. Such an easy thing, right? I hope you understand and you get it as I got it very easily. Always remember that whenever you are doing these transformations, you have to do multiplication first and then translation. Here also, you see, we did multiplication first, including the reflection, okay, and then the translation. If you do like that, you are going to get perfect transformations every time. Try sketching some graphs like this and writing functions and checking with your own values as I have shown you here. I hope you learn something from here and do a good job. We will do some more transformations in our part C. So part E was basics. Part B, we went into all the kinds of translations. I have shown you how to do them. Most important, which I feel where people do make mistake, is the horizontal translation. So when we say half of this, we check, do you see this value? Minus 6, half is minus 3. This value, minus 2, half is 1. 2, half is 1. So this is what we mean by half of this value. Compressing horizontally by a factor of 1 over k. Okay? Yeah, thank you.